We live on a small planet, orbiting an average star. Our sun is just one of billions within the Milky Way galaxy. The Milky Way itself is but one galaxy among billions in the observable universe. Contemplating these vast scales can be humbling, yet it also ignites a profound sense of wonder. We are part of something much larger than ourselves, a cosmic tapestry woven with stars, gas, and dust. Our journey begins with this perspective, acknowledging our place within the grand scheme of the universe. Galaxies are vast systems of stars, gas, dust, and dark matter bound together by gravity. They come in a variety of shapes and sizes, ranging from dwarf galaxies containing a few million stars to giant elliptical galaxies containing trillions. Each galaxy is a dynamic entity, with stars constantly being born and dying, gas and dust swirling in intricate patterns, and dark matter exerting its unseen influence. The visible components of a galaxy, the stars, gas, and dust, emit light across the electromagnetic spectrum. Astronomers use telescopes to capture this light, allowing us to study galaxies near and far. By analyzing the light from galaxies, we can determine their composition, their distance, and their motion. This information helps us piece together the story of galaxy formation and evolution. Dark matter, an invisible substance that makes up a significant portion of a galaxy's mass, plays a crucial role in its structure and dynamics. Although we cannot see dark matter directly, we can infer its presence through its gravitational effects on visible matter. The nature of dark matter remains one of the biggest mysteries in modern astrophysics. Galaxies exhibit a remarkable diversity of forms, each a unique expression of the forces that shaped it. The most common types of galaxies are spiral galaxies, elliptical galaxies, and irregular galaxies. Spiral galaxies, like our own Milky Way, are characterized by their spiral arms, where stars are actively forming. These arms wind outward from a central bulge, a dense region of older stars. Elliptical galaxies are more rounded, ranging from nearly spherical to elongated ellipsoids. They contain mostly older stars and have little ongoing star formation. Elliptical galaxies are often found in dense clusters of galaxies, where interactions between galaxies can strip away their spiral arms and lead to mergers. Irregular galaxies, as their name suggests, lack a well-defined shape. They often appear distorted or fragmented, perhaps due to interactions with other galaxies. Irregular galaxies can be rich in gas and dust, and they can exhibit high rates of star formation. These galaxies provide valuable insights into the processes that drive galaxy evolution. The formation of galaxies is a complex process that began in the early universe. Shortly after the Big Bang, the universe was a hot, dense soup of particles. As the universe expanded and cooled, small fluctuations in density began to grow under the influence of gravity. These density fluctuations eventually became the seeds of galaxies. Over time, gravity pulled together gas and dark matter, forming larger and larger clumps. These clumps continued to collapse, eventually reaching densities high enough to ignite the first stars. The first stars were massive and short-lived, exploding as supernova and enriching the surrounding gas with heavier elements. As more stars formed, they began to organize themselves into larger structures, eventually forming the galaxies we see today. The process of galaxy formation is ongoing, with new stars constantly being born and old stars dying. The universe is a dynamic and evolving place, and galaxies are at the heart of this cosmic dance. Section 5. Galactic Evolution, a Dance Through Time. Galaxies are not static objects, they evolve over time, influenced by internal processes and interactions with other galaxies. Star formation, supernova explosions, and galactic mergers all play a role in shaping the evolution of a galaxy. Over billions of years, galaxies can transform from one type to another, their shapes and compositions changing dramatically. Galactic mergers are particularly dramatic events, where two or more galaxies collide and merge into a single larger galaxy. These mergers can trigger bursts of star formation, reshape galaxies, and even lead to the formation of supermassive black holes at the centers of galaxies. The Milky Way itself is thought to have undergone several mergers throughout its history. The study of galactic evolution allows us to trace the history of the universe from the formation of the first stars to the present day. By observing galaxies at different distances, we can look back in time and see how galaxies have changed over cosmic time. This information helps us understand the processes that drive galaxy formation and evolution. Section 6. The importance of galactic studies. Studying galaxies is crucial for understanding the universe. Galaxies trace the distribution of matter on the largest scales. They reveal the history of the universe and the nature of dark matter. Galaxies test our understanding of fundamental physics. Extreme environments in galaxies probe the limits of our theories. Studying galaxies helps us understand our place in the cosmos. Section 7. Our galactic neighborhood, the Milky Way and Andromeda. The Milky Way is a barred spiral galaxy with hundreds of billions of stars. Our solar system is in one of the spiral arms. Andromeda, our nearest large galactic neighbor, is even larger. It is 2.5 million light-years away and approaching us. In about 4.5 billion years, they will collide and merge. Studying these galaxies provides insights into spiral galaxies and galaxy evolution. Section 8. Galactic collisions, a cosmic ballet. Galactic collisions are spectacular events that reshape galaxies and trigger bursts of star formation. When two galaxies collide, their stars and gas clouds interact gravitationally, leading to a complex dance of orbital motions. While individual stars rarely collide due to the vast distances between them, the overall structure of the galaxies can be dramatically altered. The gravitational forces during a collision can distort the shapes of the galaxies, pulling out long tidal tails of stars and gas. The collision can also compress the gas clouds within the galaxies, triggering intense bursts of star formation. New stars are born at a rapid rate, illuminating the merging galaxies with a brilliant display of light and energy. As the galaxies continue to interact, they eventually merge into a single, larger galaxy. The merger process can take hundreds of millions or even billions of years to complete. The resulting galaxy often has a different shape and morphology than the original galaxies, reflecting the complex interplay of gravitational forces during the collision. Section 9. The role of dark matter in galaxies. Dark matter plays a crucial role in the formation and evolution of galaxies. Although we cannot see dark matter directly, its gravitational influence is evident in the motions of stars and gas within galaxies. Observations show that stars in the outer regions of galaxies rotate much faster than expected based on the visible matter alone. This discrepancy suggests the presence of a large amount of unseen matter, which we call dark matter. Dark matter is thought to form a halo around each galaxy, extending far beyond the visible disk of stars and gas. This dark matter halo provides the gravitational scaffolding that holds the galaxy together. Without dark matter, galaxies would not have formed as quickly or as efficiently as they did in the early universe. The nature of dark matter remains one of the biggest mysteries in modern astrophysics. Scientists are actively searching for clues to its identity through a variety of experiments and observations. Understanding dark matter is essential for understanding the formation and evolution of galaxies and the universe as a whole. Section 10. Galaxies as probes of the universe. Galaxies are not only fascinating objects in their own right, but they also serve as powerful probes of the universe. By studying the distribution and properties of galaxies, we can learn about the large-scale structure of the universe, the expansion history of the universe, and the nature of dark energy. Large-scale surveys of galaxies have revealed that galaxies are not randomly distributed throughout the universe. Instead, they are clustered together in filaments and sheets, forming a vast cosmic web. This web-like structure reflects the initial density fluctuations in the early universe that seeded the formation of galaxies. By measuring the distances to galaxies and their redshifts, astronomers can determine the expansion rate of the universe. These measurements have revealed that the expansion of the universe is accelerating, driven by a mysterious force called dark energy. The nature of dark energy is another major unsolved problem in modern cosmology. Section 11. A universe of galaxies, continuing the exploration. The study of galaxies is a journey of discovery, a quest to understand the universe and our place within it. From the majestic spiral arms of our own Milky Way to the distant clusters of galaxies at the edge of the observable universe, galaxies offer a window into the vastness and complexity of the cosmos. As we continue to explore the universe with ever more powerful telescopes and sophisticated instruments, we are poised to make even greater discoveries about galaxies. New observations and theoretical models are constantly refining our understanding of galaxy formation, evolution, and the role of dark matter and dark energy. The universe is a vast and mysterious place, and galaxies are at the heart of its mysteries. By studying galaxies, we are not only learning about the universe, but we are also learning about ourselves, our origins, and our place in the grand cosmic scheme. The journey of exploration continues, and the universe of galaxies awaits our further exploration.